Hello, hello, everyone. Good morning, or good afternoon, or good night, depending on where you're at. I'm Shab. I'm so excited to see you all trickle in. So yeah, we're gonna get started at the 5 minute mark. But in the meantime, I would love to know where folks are joining in from. So if you could drop your location in the chat, that would be awesome.
Great to see.
Jörg, how are you doing today?
Pretty good. I mean, if I look outside here, San Francisco is sunny today. It was pretty cold this morning, but very excited. I mean, those are some of my favorite topics to talk about. Data mesh, ML, Gen AI, how it's all coming together. So very excited to be here with, yeah, a few of my favorite topics. And thanks everyone for joining.
Yeah, I'm not taking a look at the chat, but I also have some polls that I would love folks to jump in on. So the first poll is, what is your biggest data pet peeve? There's messy data sets, lack of documentation, too many stakeholders, unreliable pipelines, and overused buzzwords without clarity. I mean, I'm a documentation girly, so I would say that one, but looks like we're
Why
getting
is it, why is that single choice?
it's
Yeah.
oh, good question.
For me, I feel like I want to click all of the above here.
Oh, hi, Olga
Mm,
from
mm.
Chicago. Thanks for joining. Fun fact, I was born in Naperville and I lived there till I was 7. It's wonderful out there. Okay, so for the poll, looks like overused buzzwords without clarity is at 36%. At number 2, we have messy data sets. Lack of documentation and too many stakeholders is tied. And then unreliable pipelines comes in last. Awesome. Let's
Yes.
do another one. So,
We will deal with that buzzword factor. I feel like you just set me up uh for the first slides of this presentation here.
um,
Mm,
so
mm,
for the next
mm,
question, what's the most common villain in
mm.
your data workflows? So we have data silos, manual processes, dirty or incomplete data, unclear requirements, or time or lack thereof. So, seems like we're getting a clear winner with data silos, but we also have unclear requirements second, and manual processes close behind that. Dirty and or incomplete data. And then last but not least is time. Okay, and let's do one more. These are fun. If your career in data was a movie genre, what would it be? So action adventure, always solving problems under pressure, comedy, those pipeline failures though, mystery, finding hidden insights in messy data, science fiction, pushing the limits of what's possible, drama, stakeholder meetings can get intense.
What about thriller?
Oh, you got me there. I mean, mystery could be thriller, right? Okay, a lot of folks are living an action adventure. And then we have mystery and drama at a tie, comedy behind that, and science fiction. Very cool. Wonderful. So we're at the 5-minute mark. Without further ado, everyone, once again, thank you all for coming. Really excited to get this started, but I'm going to hand it off to our amazing host and speaker, Jörg Schad. Jörg, take it away.
Thank you so much, and thanks everyone for joining. As mentioned earlier, those are two of my really core topics I deeply care about, which we're going to talk about today, and that's data management, and that is ML, GenAI, kind of new applications on the other hand. And the other fact I really enjoyed were your answers around buzzwords, overused buzzwords. And so, I mean, MeshRAG is up here on the slide. So let us actually ask that first question. Do we really need another buzzword with MeshRAG being out there? Probably if we look at it, GenAI and LLMs were most likely the biggest trends over the last years and have been used a lot in, I would say, in sometimes also in the capacity of buzzwords. So let us see what's actually behind it. I think many of us, we've actually tried ChatGPT when it was come out, and I was super impressed by that, just being able to chat with that system. But in my opinion, in my experience, the real value of GenAI is realized when we start enriching it together with custom data. So our enterprise data, not just the training data inside an LLM, which OpenAI scraped at some point, but really like our up-to-date current information. And here, Retrieval-Augmented Generation, or short RAG, has become a de facto standard for connecting GenAI LLMs together with our custom data sets. As we all know, with the power of data also comes great responsibility and complexity. Luckily, we also know that in the data management space, data mesh is a well-established pattern and paradigm to help us solve these complexities of data management. So maybe the question should be here, is data mesh actually relevant for GenAI applications? Or do GenAI applications require yet another paradigm because they're fundamentally different? So,
Jörg, we
yeah,
just got a message that they can't see your slides, so I'm just going to go ahead and make you the host.
okay,
Sorry about that.
sure. I'm in screen sharing mode, and maybe just can you double check? Just give me a thumbs up when this is working out.
And Jolly, can you see the slides? Can everyone see the slides? Yeah, they can see the slides.
Okay,
Thank you.
thank you so much. You haven't missed much. Let me just quickly step through again. As said, like here, GenAI and LLMs, as mentioned, probably the biggest trend out there. RAG, the pattern, adding and allowing us to connect GenAI capabilities, those natural language capabilities together with our own custom enterprise data. And then as mentioned, is data mesh, which we know can help us solve complexity on the data management layer. Can it also help us solve issues and complexities for GenAI applications, or is actually ML and GenAI different? So we might yet require another paradigm. Let's explore that in this presentation. And so for this, to answer this question, we will actually take a look and explore a potential GenAI stack, right? Which will also help us guide through this talk. One short disclaimer here, you'll see some of those stars. So, and you'll notice during the remainder of this talk that we sometimes need to distinguish between the data mesh paradigm being pushed out in the book and particular implementations of data mesh. So a number of different implementations and interpretations have arisen since the concept was introduced. During this talk, I will typically refer to Nextdata OS, the implementation we are building here at Nextdata, which, as probably most of you know, is actually driven by the founder of Data Mesh, Zhamak, herself. So, with that, who am I? I'm Jörg. I'm head of engineering here at Nextdata, and it feels like the job description was really designed just for me, as it combines my two professional passions. First of all, I really enjoy building large-scale distributed data-centric systems, especially database systems back there with SAP HANA, or for the 5 years prior to Nextdata with the RangoDB graph database systems. My second passion is really building large-scale orchestration platforms. I worked early on Apache Mesos and Kubernetes before it was as big as it's right now, and in particular worked with a number of users and customers to build data and also machine learning applications and platforms on top of that. And trust me, I really wish Data Mesh had been around those times. It would have saved me countless hours of sleepless nights. Okay, let's jump in. To get started, let us understand what are the challenges with GenAI-based applications. So, to recap how RAG allows us to build and connect those GenAI capabilities with enterprise data. Let us imagine we want to build a chatbot to answer questions around product feedback. So for example, here, is a certain user group less satisfied with a product? What do? We pick out our favorite tutorial for building a RAG pipeline, which are tons of there out there, and we'll identify our inputs. So in our case, we have two potential inputs. First is, for example, PDF feedbacks really scanned from the point of sales, from the stores. We receive those every week and just kind of like a S3 bucket, for example. And on the other hand, we have kind of like a bit more timely Amazon reviews coming in. Those are being stored typically in like a relational system. So we could, for example, have a Snowflake database storing all those Amazon reviews coming in. So this is kind of the first step. These data points, they then get fed into an embedding model. So for example, a text to vector embedding model, taking these structured and unstructured data and turning them into long sequences of vector or vectors, or also referred to as embeddings. That depends a little bit which community you're talking about. Either you talk about embeddings or you talk about vectors. Typically, we refer to, in the GenAI space, we refer to the same concept, long sequences of numbers representing a certain concept in a high-dimensional vector space. These vectors or embeddings are typically stored in a dedicated vector database, or also nowadays, many standard database systems such as Snowflake, MongoDB, they offer vector support as well, so we don't necessarily have to switch to a particular system. Still, in my experience, a dedicated system, if I really need to rely on a lot of those vector database systems, especially high-dimensional search capabilities, often the dedicated systems will still be very useful for that. And then finally, our LLM, some model, either in ChatGPT model, GPT 4.0, or one of the newer models, we can utilize them. They will kind of fetch those embeddings and leverage them to answer a particular question. As said, our question here to start out with, is there a certain user group less satisfied with a product? And then the LLM can take this natural language question, utilize the embeddings, and produce a natural language outcome. Great. So we've just built our first RAG application, but immediately people across the org will actually voice their concerns. The CISO might wonder about data safety. Are we exposing any PII data throughout this flow? Might we expose any company secrets outside with that new chatbot? Data engineer is concerned about having different modalities, like on the left side, our PDF or Amazon reviews in our relational database systems, and those embeddings getting out of sync. They might be very far apart, so we are not getting the most recent outcomes. And probably most crucially, the end user might come up very unsatisfied with the quality of results, the answers he's getting, which as often in ML might be a result of bad input data quality. So I think with ML and GenAI, as we are talking through those vectors, which is really hard to validate, right? I cannot go into my vector database and say this first row is representing this particular concept. It gets a lot harder to validate data quality at this later stage. And so I've seen a lot of ML projects fail or not deliver the outcomes they were set out to, simply because data quality, and that can be as simple as missing columns or incomplete data or different formats that will really kind of impact the quality of the answers at the end. So despite those critical voices, your teams want to build even more GenAI applications. We already talked about it, probably one of the big trends over the last years. But this in an enterprise setup can even lead to more challenges. So for example, how do we deal in an enterprise with a sheer number of different data sources available? In our example, we had a pretty simple choice. We could just pick two, which were pretty well defined. But in a large enterprise, how can I identify the available data, and how can I also pick the ones relevant for a particular question? How can we react to updates in the underlying data sources? So we already talked about it. The data engineer might be concerned about them not being up to date, but there are also more critical things like, for example, what if the semantics of the data changes, right? It's not going to break it immediately, but again, we will end up having very bad outcomes or potentially even incorrect answers being provided. Typically, the data sets we rely to in an enterprise setup, they're not static, they're very dynamic. How do we, in an enterprise setup, gain access, permissions to access the data sets? Probably all of us have gone through that. Who do I need to talk to get access to this data set? And that might also take time. So how can we actually incorporate that into our RAG application here, which might want to access different data sources? And again, this is also something dynamic, which might change over time. I might get more permissions. My user might get more permissions. I might get less permissions over time. So how can I also deal with those more dynamic permission setups? And again, kind of the CISO voice coming up here. How can I enforce central governance policies? Like if I'm using that data, maybe certain parts of my data sets are not allowed to be processed in certain countries on the server. So I all of a sudden have to care about where's my embedding model running, where's my LLM running, where is it, in which kind of cloud environment, in which country. So all of those are challenges as soon as we start to really engage and gain value of GenAI applications in an enterprise setup. Okay, those challenges, like on the good side, they actually sound familiar. We have experienced a lot of that in data management before, and kind of our answer to that was data mesh. So let's take a look at that in more complex, in more detail. So motivation for data mesh back then was the observation that building static pipelines was getting complex and getting very messy, right? Just if you look at this picture here, we often end up with architectures where it gets really hard to trace each individual pipeline. And this forces us to put a lot of little bandages, little tools to solve this issue arising, to solve this issue arising, to keep our architecture, to keep our data somehow manageable. So basically, we start kind of like putting a lot of bandages out there. And that was kind of something we observe here as well, even though it looks a bit more clean. I wanted to relate it back to the original picture, but actually we have very similar loops in our data. Just imagine, for example, features. They might be derived from data as well. They might actually feed in and being used as another input source again. So we actually end up having loops here as well. And as mentioned earlier, I think one of the big challenges making GenAI and ML is more complex, that we actually turn our data into a different representation. So all of a sudden, I cannot go in and validate this vector because it's really hard to attach any meaning to those different dimensions. What does this 2 at the beginning mean? What does a one mean? It is typically an abstract vector space we are dealing with. So my domain experts, they cannot go in and validate at these later stages that my data is actually correct. So as mentioned, data mesh was kind of like going out to solve some of those challenges in more traditional data management. And I mean, the beginning, there was actually even a step before, but I couldn't find any screenshot of the original talk. There was a talk by Jean-Marc in 2018, and then followed by this blog post. And I think a lot has happened since. If you look at Google search trends, if you look at also other books being published around that, if you see a lot of people interpreting and implementing, adapting the data mesh paradigm, it's really amazing to see. And also like on Jean-Marc's side, I mean, since then there has been the data mesh book, and also luckily for me, there is Nextdata as a company really dedicated to building a product, productionalizing data mesh with the best practices and also lessons learned since. So what makes Nextdata OS special or different also from other implementations of that data mesh paradigm? That probably deserves its own webinar, or more likely probably an entire series of webinars. So I here want to focus on the two key aspects most relevant for the remainder of this talk. But first of all, there's a concept of autonomous data product containers. They allow each team to actually go in and deploy their own data products. And then they containerize a particular data product into an autonomous unit, which is offering, for example, also well-defined functionalities, a common API, some of which we'll explore further during this talk. Coming from a database implementation background, I often imagine a data product container being a logical operator, being a logical abstractions of the physical representation. So for example, during query optimization inside database systems, you typically start out by optimizing logical operators, for example, a join, and then later you bound it to a physical representation, a sort merge join or something like that. And I think this is often what I imagine when also looking at data product containers, because they give me the contained unit, a well-defined interface I can operate with, and then I can tie it down here to the physical data plane underneath. So by relying on those standardized container, the entire mesh will exhibit a number of very powerful emergent functionalities. And these are, for example, captured or exposed in the Nextdata's case by data mesh OS services. So for example, aggregating and orchestrating these standard containers, the OS services, they can offer information such as real-time discovery, mesh insights, which data products are being used, which data is being used, which data is most valuable to my company, or for example, like routing information such as, or lineage information, which we'll also see in a bit. So that was like really short, in a nutshell, relevant for this talk explanation. If you want to know what data mesh is for real, I, of course, must defer to a lot of great material being out here by Nextdata and especially by Jean-Marc. Not sure whether she's actually in the audience, but for a more detailed and nuanced explanation of both the data mesh paradigm and the Nextdata OS implementation, I would highly recommend to check out our website, nextdata.com. From time to time, we try to keep it up to date and supply more and more resources. And also, for example, just follow our LinkedIn page if you want to be up to date. So, okay, we've learned about autonomous data products. Let's actually now take a look what that implies for RAG-ready data products, and also like what are actually RAG-ready data products out here. Just another buzzword, or is it more to it? Good news, autonomous data products are inherently RAG-ready. We don't have to learn yet another buzzword, but let us explore what they are and how they can support us with some of the challenges we've sought out and visited earlier. So to do that, let's actually build a particular data product following our motivating example of building like a product feedback chatbot. As discussed, we have two distinct data inputs. In our case, of course, data products themselves. There's a point of sales PDF documents, which, for example, might be stored in the physical representation in a bucket system, for example, in a S3 bucket, and then our Amazon reviews being stored in Snowflake or some other relational database systems. Here already the first benefit of the autonomous data products is coming in. We can validate. It's basically here, it's the integrity and quality verification, that little check mark here on the left. We can have computational integrity and data quality checks. So with using those, we can ensure that incomplete or incorrect data doesn't propagate to our transformation, to our data product itself, and therefore also further throughout that mesh. In our case, prevent end users from getting incorrect or not high quality results by blocking out bad input data quality. Second inherent benefit on the input side is kind of the orchestration of inputs. Already in this case, which is a pretty simple one, we have two inputs, which both very different rates of updates, right? The point of sales, customer feedback PDFs, they might be scanned once a week. The Amazon reviews, they might be updated like every minute or whenever someone reviews our new amazing product on Amazon or somewhere else. So a question arising here is, how often do we want to recompute our embeddings? When is it meaningful to recompute? With every new Amazon review, probably not. That might get really expensive, computing a model each time, and the value will be very minimal to that. Then on the other hand, every week when we get like this new chunk of point of sales forms being filled out by the customers in the store, that's probably too slow, as we might miss relevant trends if someone, for example, like posts on social media or a new product is being released. Luckily, data product containers, they give the developer of that data product the option to define trigger policies. So they can control the desired rate or the desired triggers for updates, the situations when we should actually run the transform, create a new embedding, create a new outcome. That brings us to the transformation itself. As mentioned earlier, I often view it as a logical abstraction. So, for example, this allows us to switch the underlying function or change the execution environment. Imagine our embedding service first is implemented as a simple Python job. Now we want to move that to a remote Spark job. We can do that without impacting our input or output side, as long as we adhere to the same semantic model, kind of the same output promises I'm making on the other side. I can change the physical transformation. Here again, on the output side, moving to the output side, these promises of the semantic model are automatically verified. And also I can define additional custom data quality checks, which again are validated each time I output kind of like a new version of my data. Again, this is very crucial to have high quality data downstream and high quality answers from our chatbot we are building. As we're already talking about the output, we often have different consumers being interested in our data, and they might prefer different formats. So for example, our chatbot is really relying on those embeddings because this is what it takes. On the other hand, a data scientist might be interested in also analyzing the customer feedback we have gathered, summarized, cleaned up here. So, but they probably are going to prefer some kind of SQL-based system where they can use their notebooks, Power BI, or other tools. Yet another option would be an engineer who wants to fine-tune our embedding model or wants to build yet another machine learning model on top. They probably require data access in some kind of file format, some kind of document forward, as kind of like the training input to the fine-tuning or training job down there. Again, here, autonomous data products offer really great capability called multi-model output. So that basically allows us to offer the same semantic data model across different physical representations for different users. So with that, the RAG-ready data product already solved a number of our initial challenges, in particular, data quality. And I think I just want to reiterate, that's probably the most important thing to look out for, because it's really hard and will have a high impact on your overall model and quality perception by the end user. The other is then the input orchestration. How often do we run it? How do we keep our outputs up to date without running it all the time and spending a lot of money? And then also, how can we cater to different consumers downstream with the multi-model output capabilities? Okay, great. We learned about what a RAG-ready data product is, but how does it actually scale to more of those in an enterprise setup? So in an enterprise setup, we're not just going to have one of those data products, but we're going to have a lot of data products out there. So at enterprise scale, we are therefore facing a number of additional challenges, particularly just the sheer number of data products, sources available, the dynamic nature of them being updated, permissions being moved, and also, as mentioned before, just how do I access them? How can I get access to that information being stored in S3? So if we want to build our next version of our chatbot being able to answer more questions, we have to look into questions. How can we select the relevant data products out there, right? So we want to not just be able to answer questions about product reviews, but also include more information. Or there might actually be a new data source popping up, also including customer feedback information. How can we make sure that our chatbot is always going to rely on all relevant information being out there? A question I usually get asked here is like, hey, why didn't we just give it like all available data to the LLM? I mean, first of all, there are a number of papers, feel free to ping me, happy to share some of them, which actually tell the quality of our answers is going to go down again, right? So the more specific we can have the input to the LLM we are supplying via RAG, the better our outcomes. And the second point is it's also simply costly, right? The more tokens in LLM speech we use, so the more input we give to it, the more expensive it's going to be to compute the answer. And we're going to see that bottom line at some point, like how much does it cost us to answer each of those questions out there? Furthermore, as mentioned, how can we add new data products? How can we make sure they're incorporated? How can we update existing data products? How can we change those access permissions? So usually we don't have like a master key with access to all the systems. So how can we make sure that our embedding can always access and also write to the underlying data systems? So I think those are some of the challenges we'll see. Then there's centralized governance. There's supporting like new database systems underneath. So how can we solve all of those challenges in a more enterprise setup? So this is introducing the MeshRAG pattern, right? At the first step in MeshRAG, we want to select the relevant data sources. Again, keep in mind the goal we are trying to solve here is we want to be able to answer more general questions throughout our data set inside our enterprise. So for example, here's still a very similar question. How does product feedback impact sales? So you already see we require data from at least two different domains. There's the feedback, the customer feedback, and there's kind of like the sales domain. So we at least need two very different sets of domain information here. So therefore, the first step in the MeshRAG pattern is we select the relevant data products in this dynamic environment. And for this, we can leverage the OS services. As mentioned before, they're one of those cornerstones, at least of the Nextdata OS implementation of data mesh. And you can even imagine them as like small data products offering aggregated mesh information, right? So for example, we can make those choices, which data products to choose based on the semantic data model, which we can get from our OS level services through the real-time discovery API, for example. We can also include data freshness here. So imagine we want to build a data product giving me updates about what has happened in the last week's reviews. Like, have they gotten better because we did this change? Have they gotten worse? So therefore, any data product which hasn't been updated for a couple of months, for example, probably won't give me relevant information. So I can most likely, in most cases, will ignore that one. Data lineage, I think, is another great term which the aggregated OS services can offer to me. So I can actually query around the context, right? In that decision, what is relevant, I'm not only taking into account that one particular isolated data product, but I'm actually taking into account the context around it. What other data products have contributed to it? What other what are other consumers on the other hand? In my previous life, I've been working a lot on graph machine learning, and like one of the key learnings for me was like that context is often so important. So we often lose a lot of information and potential drivers to a better outcome by just being focused on an isolated item. So I think the term mesh or data mesh already implies that we can actually look at information in context, and this is also being offered here. So I think those are some of the things in step one, which the data mesh routing is going to take care of. And then based on that information for a particular question, we can select the best candidate data products with information, right? So we've selected 3 here, and those are the ones we actually want to get the embeddings from. So we need to access their embeddings and then feed them kind of like back to our LLM. So for that, we again have a number of challenges. So first of all, how do we identify the embedding output? We mentioned those data products. They might actually offer multi-model outputs in different modes. Luckily, there's semantic information attached to that, so I can identify which output I need to access, which output port, and also how to get to it, right? And this is the second part on the permission side. How can I get the actual permission to the underlying data? As mentioned, that might be stored like in that underlying physical layer down there. So those embeddings, they might be stored in a dedicated vector database. They might be stored in Snowflake. They might be potentially even stored in a file somewhere on S3, but I still need to be able to have the permissions to access those. And a data mesh, again, through the autonomous data products, they offer an auth API where I can kind of like identify how to get access, or even if the system is configured in that way, request temporary access to that data set. All of that together allows us to automatically retrieve all our relevant embeddings. And then we are pretty much in like a normal pattern. We do the LLM inference, meaning our LLM together with all those embeddings is kind of like leveraging them to come up with the best output for our task or for our question. I think this is, in short, these are kind of like the steps in our MeshRAG architecture, in our MeshRAG usage pattern here. And there's kind of like one bonus, right? I mean, we talked a lot about the different personas, but while doing all of that, did we forget about the CISO? His concerns are governance and data safety. Luckily, this is also inherent to the data mesh implementation, to the data mesh Nextdata OS implementation, by leveraging, again, offered through OS data mesh OS services. We have a governance and lineage traversal APIs. Those in traditional ML architectures, you probably would need some other bandages. You would take a tool to kind of keep track of this lineage to be able to figure out where is this data coming from. Is there any PII data somewhere downstream which might have influenced the system, and therefore we are not allowed to share that data or store it on particular servers? Luckily, you don't need a separate tool for that because, again, it is an inherent property of data mesh arising from the use of autonomous data products. So we basically get data lineage tracking. We also get policy enforcement. I sometimes call that like actionable lineage tracking. Imagine we know, hey, here's some information we cannot use. I can kind of like flag or have a traversal deleting it removing it from the outputs throughout my downstream consumers. And also I basically get away for audit logs, even not just focused on a single data product, but focused on a lineage, the entire lineage of our decisions, basically for free as an inherent property of the data mesh. Great. Again, just looking back at some sleepless nights, I'm not sure whether Jean-Marc actually foresaw all those challenges, but I really wish I had those tools when I was working in like healthcare AI, and that would have saved me some sleepless nights with a lot of SQL joins trying to reconstruct exactly this lineage property here. Okay, that leaves us with a question. Is what we just talked about, is that MeshRAG architecture, is that MeshRAG pattern something special out here? If we start to look at our initial stack here with the RAG-ready data products, with the MeshRAG architecture, and we broaden our view a bit to a more general data management perspective, with data mesh being a socio-technical paradigm out there, autonomous data products and data mesh OS services being a specific implementation of this paradigm, data mesh enabled architectures being built on top of this application, leveraging the data products, leveraging those OS services, and data applications being built on top of that application. In that case, it is not special. It is MeshRAG is just a special instantiation of the data mesh enabled architecture. So we here then RAG-ready data products, and we said that earlier, are it's an inherent property of autonomous data products, and similar those data mesh OS services, they give me all the information I need out there. So it is actually not something special. If we want, we can save this one buzzword potentially. And it kind of like brings us towards the end of this talk. If there are just two key points you take away, if you had known before, I would say those 2 points are most crucial to me. First of all, GenAI and ML are really dependent on a solid data management foundation. I often feel when looking at those tutorials or kind of like how to get started on this, I often feel this is missed, that I'm not going to build any successful production grade system without having a solid foundational layer of data management below. Luckily, Nextdata OS or that opinionated particular implementation of the data mesh paradigm based on autonomous data products and OS services is inherently offering such foundation. So we can kind of like answer all our questions. The CISO can make sure he keeps his governance and data privacy safe. The data engineer can make sure he's orchestrating his inputs and keeping his embeddings up to date. And most importantly, our end users are going to have high quality outcome, high quality answers. As mentioned, MeshRAG architecture is just an data mesh enabled architecture, leveraging those. So that kind of brings us back to our initial questions. Do we really need another buzzword? I would leave that up to you to decide. But with that, thank you so much for listening. If you want to learn more, jump over to our website. There's also right upper corner here, get early access. If you want to be first in line to get access and a glimpse of what we are building out there, I can just tell you it's pretty exciting. And otherwise, please, really excited for questions coming up here.
Yeah, so we have one question from Kat Holmes. What role do you see for an enterprise data catalog like Calibra in this architecture? For example, the access management requirements are embedded in the data product asset record in the catalog.
Yeah, when I read quite a while ago, I think there's also a book behind me, but I don't see it right now, about catalogs. When I first was thinking about catalogs, it kind of felt like a very like one of those bandages I talked about earlier, trying to solve a particular problem arising from the complexity of data management. I think in these architectures, they can become a consumer of those APIs, right? If I would implement a catalog and I had the data mesh APIs available, Uh, Great. And I think this is how they will actually come together in a larger kind of reference architecture. I think there will be a certain symbiosis where they can actually consume the APIs and actually lead to better insights throughout the catalog. I think one of the, for me, for example, like one of the differences, I often feel catalogs, they give me like the early catalogs, right? I think catalogs also have evolved. So I just want to qualify that to early catalogs often just gave me like a view of what is there. Whereas, for example, data mesh actually allows me to have that actionable, right? If I'm saying, hey, this is a semantic data model, I want to stop it from impacting anything else. I'm not sure how many of you have actually debugged um, some ETL flows because someone changed the schema somewhere very, very high up, and then all the entire pipeline broke. I think this is where kind of data mesh can collaborate with catalogs to give a more actionable insight and actually stop that from propagating. I hope that makes sense. Otherwise, I'm pretty sure if you follow our website, there's also going to be some more dedicated blog post or something like that coming up for this particular topic.
Awesome. Thank you, Jörg. The next question we have is from Sandeep. Unlike data mesh, which exposes data product as an API, here it seems data product is directly exposing the embeddings.
Very good question. Let me I think this is a little bit, if you recall the physical layer underneath, so the embeddings, they are logically directly exposed, right? I mean, technically they still get written into an underlying storage. And if you want, the data product gives me the APIs to access them, right? So this is just a little bit whether you're asking it on a logical layer or on the physical layer. So I would still say it is exposed as an API. Just if you think about logically, they expose those different outputs potentially in different physical systems underneath.
Thank you. Another question we have is from Pascal. How exactly does the data quality filter work? How can you
Hmm?
automatically know that this data point is high quality?
Yeah. I mean, first of all, there are certain checks Nextdata as will do automatically for you. For example, just making sure that the semantic model is there, right? There are certain things where we can automatically generate and perform those checks based on the semantic information you've given us. You can also specify, for example, freshness guarantees. If you're saying, hey, I really want to make sure this data, I'm saying like this data is updated at least once a week. And if it's not, some downstream reports might fail because they require on that most up-to-date data. This is also something we can automatically verify. You can also specify custom data checks. And in my experience, there's the basic things which might already be covered by, for example, semantic model, like missing data, incomplete data, wrong formats for data. Um, if you get a bit more complex, and again, as it's custom, you can specify that. And I often imagine just kind of like a library being available for such validation functions, are then checks around distribution of data. I've seen that myself, that, for example, if all of a sudden the distribution of data is changing in ML use cases, the model we've trained is not applicable for it anymore and not as good anymore. And that's typically a reminder that we have to retrain our models. So there you can basically drop in your custom validation functions.
Thank you, Jörg. Another question we have is, if my data is in a nice tabular form, can Gen AI work with it seamlessly and provide it data applications?
Yes, GenAI can work with both structured and unstructured data. It's for me, it always, so I think if you would come to me and say like, hey, I have the structured format, is that the best? it really depends like on your use case, right? Often, for example, if I want to work with GenAI and my data is representing a more like a graph-like structure, right? Where I have a lot of like foreign keys in there, then you just must be aware that when working with GenAI in a tabular format, it might miss kind of those connections. So with GenAI, I would say it's kind of like important to think about what is your data actually representing. But in general, the short answer is yes, it can work with that. Whether it's the best results really depends on the data you're using.
Awesome. We have another question. Can you comment on MeshRAG and agents?
I think this MeshRAG pattern we talked about here can also be leveraged by agents, right? It is in pattern. It is if agents need to interact with data. Right now, we just talked about reading access, right? For embeddings. But I think you can use that same architecture. And I hope that they came across is that MeshRAG isn't anything special. It is one pattern leveraging the specific implementation of data mesh. You can build something very similar, come up with another buzzword for that sake. You can build something very similar for agents.
Great. We kind of have like someone asked a question and then added to it, so I'm going to share both. How are you solving data quality checks on a domain when compared with data evolution, especially in an environment where external data can often change unexpectedly, like fields, types, which is unfortunately how many organizations behave. To add to my previous question, when we think of a complex pool of domains, where if we stop producing data because it's not well formed, it can then impact all downstream parallel systems. And yeah.
Yeah. So I think this is coming to like this messiness of I think implementing data mesh in general inside an organization, where typically you'll start with like some brownfield approach, right? Where data is coming from outside the mesh. Nextdata has a concept kind of for allowing those data to come in. So by basically just building a source aligned data product, which is just capturing this output, this external table, kind of like in databases, external table reference. It kind of takes that table. You can still apply the quality checks to that. And then there could be like a nice combination with those agents, right? And then you can also detect any schema changes externally, either prevent them from going in or kind of setting up an alert that something must change, right? I think that's the other nice thing with those APIs. I can actually set up traditional monitoring. Like my DevOps team can go in and connect it to like Grafana, Datadog, or something, and I can all of a sudden see like, oh, with this domain of data products, uh, the error rate of my quality checks is going up. Probably I should do something. And again, you can do that very specifically in individual domains or subdomains.
Thank you, Jörg. Another question. How are you measuring the effectiveness of MeshRAG and validating that it's not hallucinating?
Ah, this I think this is a rec question in general, but again, I think this is one of the powerful things. If you recall, we talked about lineage, right? So first of all, I still have time, right? I'll take like 30 seconds. So first of all, a lot of hallucination is coming from that fact that the LLM has been trained, right? ChatGPT models, they are trained for like with a lot of resources, with a lot of input data from the entire web. But the LLM structure itself it's a probabilistic structure, right? It's not great at storing facts. So first of all, if you're asking the LLM anything, it's probably it has a high risk of hallucination because it's not storing facts explicitly. I think this is where RAG already is super beneficial because we delegate the storage of facts to a dedicated system, to a data system, which is built for storing information and facts. And then the LLM is not relying on its probabilistic neural network inside to represent those facts, was actually accessing explicit external information. So I think, first of all, RAG in general is helping me to reduce hallucination. Second aspect to that, it can still happen, of course, but as we get the implicit lineage, so for example, by saying this answer has been provided by the easy example you'll see in all those tutorials, like this part of a PDF document. So again, kind of having the lineage out there can help me validate. And secondly, a typical pattern is, and I can implement that in my MeshRAG architecture as well, I'm just going to ask it to recheck, given that lineage information, explicit lineage information for a particular statement. So I can kind of do this iteratively. This is part one. And I think there again, data mesh and autonomous data products are giving me a great tool for that because I can capture that lineage together with context. And sorry, I'm doing yet switching to another graph analogy. If you're doing this lineage by saying like, oh, it was just this one paragraph in my PDF doc, in most use cases, it's not just a single paragraph. It is a connection. It is a graph of multiple input sources, potentially in our case, across different data products. So as the data mesh OS APIs, they can basically provide me this lineage graph, right? It's not just this one statement. I actually have a more complex lineage, and thereby I'll also get better results on this iteration. Sorry for being a bit lengthy, but I think this is quite a powerful tool.
Yeah, and we are just about at time. So yeah, thank you so much, Jörg. And thank you for everyone who attended. I saw some questions around getting a reference or a recording. We will share a recording of the event and a reference, as well as a brief survey on kind of what you learned, what you liked, where we can improve via email and ways to contact us, connect with us on LinkedIn. So look out for that sometime later today. But yeah, thank you so much to everyone who came. Thank you, Jörg. This was a wonderful webinar. I learned a lot. And yeah, we hope to see you all again soon.
Thank you so much, everyone.
All right. Bye, everyone.
Are we all?
Yeah, I have to here. Now we are. Bye, everyone.
Bye.